Good morning. We are here for Math 60, 4.2, page 4 or Quator. Thank you, Ms. McNamara. And once again, I've got my brightness kind of going a little wonky bonkers. Wonky Bonkers is my new name of my new band. Okay, so following up on the previous problem, we've got another OR problem. 3x minus 11 is less than 4, or 4x plus 9 is greater than or equal to 1. So in other words, we're looking for a union. I want all the points that satisfy this one combined with all the points or values that satisfy this one. We're going to bring them all together. Woohoo! So again, I have foolishly left myself no room for simplifying. So let me grab a piece of paper. I will number these so they're easier to follow. 1 and 2. 1, 3x minus 11 is less than 4. And 2, 4x plus 9 is greater than or equal to 1. Pardon me. A better person than I would know how to edit that out. But for today, you're just going to have to go with plague math. If I could spell plague, I'd write that down. We'll see in the transcript. Hopefully they'll have plague written out. There's a U in there that you really wouldn't expect. Like someone who's sick really needs to not have to deal with extra letters. But, so plague should just be spelled like Playg or something. That would be so much easier. But I do know there's a U and an E, and it's just all sorts of complicated. Okay, back to math, which is not complicated at all. Hopefully at this point you are just almost bored with how simple this is. Oh my gosh, look at you guys being so brilliant, knowing that we're going to add 11 to both sides. And then I'm going to divide both sides by 3. And I don't even have to ask you, like, does the inequality stay the same? Of course it does. We're dividing by a positive number. Bam, x is less than 5. Okay, let's come over here. Subtract 9 from both sides. Woohoo. 4x is greater than or equal to negative 8. Yep. Divide by 4. Divide by 4 again. Happy, happy, joy, joy. We've got dividing by a positive. No big deal. X is greater than or equal to negative 2. Awesome, awesome. So these are the simplified forms that I'm going to put back onto this. So you're going to have to remember this because I don't think I can fit them all together. It's complicated. So right here, number 1, I'll rewrite was x is less than 5. Number 2 was x is greater than or equal to negative 2. So we've got those two to graph. Awesome. So I need to graph a negative 2 and a 5. So 5, here's 5. X is less than 5, so it's going to go right here. Okay, and x is greater than or equal to negative 2, so that's going to go right here. Now, I think people are generally split on this one. It either is one of the coolest things or one of the stupidest things to happen. Feel free to take either or both position. But I'll remind you that the OR that we've got going on over here is a union, right? So we want to have x is less than 5, union x is greater than or equal to negative 2. So in other words, what I'm asking you is, I want all the numbers which are less than 5 or greater than negative 2. Now, if you think about it, any number you can think of is either smaller than 5 or bigger than negative 2. Since it's an OR, we're not looking, the AND would be right here in the middle, but the OR means we're going to bring everybody from this graph together with everyone in this graph, which means every stinking body, person, number, value, point on the line is invited. I don't know if you've ever been to one of those parties. They get kind of noisy. Math teachers, I think, tend to like the, much smaller parties. That's not true of all of us. I'm having a party of one. I mean, when there's math and a yellow highlighter, it's a party. Okay, so the answer is it's the entire line. We go from negative infinity to positive infinity, or you could also say all real numbers. Bam. We're on the last one. I know you're as excited as I am. This is pretty exciting. 4.2 is almost done. I know some of you are sad to see it go. Maybe, possibly, but you won't be once you see this problem because, again, I told you that when I give you a single statement that has a double inequality, that's usually one of my favorites. So, what would be wrong with this? Why would this be the last one, the death problem? Well, the answer is hopefully you've noticed already there's a -3 in there. Now, you can wiggle and squirm and try to get rid of this, but I'm going to warn you that there aren't really good ways to deal with this except to multiply. So I am going to go ahead and multiply all three sides. Remember, we've got this situation where you've got a double inequality, two inequalities. I got to multiply everybody by -3. So I'm going to multiply negative. Oh, well, that's exciting. -3 times -10. Sorry, my brain was just going to multiply by a negative. Over here, -3 times -8. And right now, I love myself so much for having given myself almost no space to do this. Okay, so everybody gets a -3. Let's see if I can get away with. If I can, hopefully I won't just smear everything. Little smear. Little smear. Sorry about the smearing. Basically, everybody gets a -3. Now, there's almost no room left. So I regret this a lot. But what we're going to have to do is figure out each time we multiply by a -3, the inequality turns around. So both of these, let me write this down here. Over here, I get 30. Over here, I get 24. And right here in the middle, let me stick my pen in, the -3's cancel, and I get x plus 6. This inequality came right here. Do I have, let's see, I do have a whole assortment of colors. How's that showing up? Oh, that is a hideous color on this video. The orange one turns around in place. And just to complete my collection of hideous colors, how's that? Oh, great. Okay, so, but hopefully you can distinguish this. This inequality turns around in place right there. This inequality turns around in place right there. I multiplied everybody by -3. Sorry about getting a little squashy, too small. But here we go. We've got 30 is greater than or equal to x plus 6 is greater than or equal to 24. Now, this was a lot of work. One of the things you can do is make sure the alligators, the inequalities are still facing the same direction. They're both going greater than. Wait, greater than. Anyway. I need an alligator. That would be so cool. They both face the same way. And in fact, I see that on the larger side is 30 and on the smaller side is 24. So logically, it still makes sense. I'm going to go ahead and subtract 6 from all three sides. 24 is greater than or equal to x, which is greater than or equal to 18. I'm going to rewrite this exactly as it is. And then I'm going to very carefully, I'm going to turn the whole thing around. I'm going to start with 18 is less than or equal to x is less than or equal to 24. So I took the whole thing and flipped it around. I'm just writing them in a different order so that it progresses the way it would on this graph. I can draw the 18 in first, the 24 in second. These are both brackety guys. Now, after a problem like this, and you're like, oh man, that was a lot of work, what can you do? Well, inequalities are really hard to check. However, if you pick a point in here, we could pick 20 or 22, whatever number you'd like, maybe even 21. If you plug it in up here, it should work out. So like if I pick 21, the number 21 is in here. If I come in here, 21 plus 6 is 27. Divide by -3. 27 over -3. is -9. Oops, sorry. Ooh, there we go. -9. Does -9 sit between -10 and -8? The answer is yes, it does. So at the very least, this point, which sits like right about in the middle of here, this point, it should be on the graph, and it is on the graph. So that makes me feel better. Now, to really check the inequality, you'd have to check all the points, or at least the end points. I'm not going to do that right here, but you can go ahead and do it. But we are done with 4.2. Woohoo! Yay us! Yay!